So I was asked why do we have to do the check to see if we can use the normal approximation for the binomial distribution? And specifically, somebody asked about a web MyOpen Math assignment where they said where in MyOpen Math they said here, let me get a pointer going here. They said n times p has to be bigger than 10. Well, Dr. Stevens uses 5, and so does it really matter whether it's 5 or 10? What we want to do is, and if you remember back to back in chapter 3, we said um, if we have a symmetric distribution, we should be using the mean and the standard deviation to describe center and spread. And if it's not, we should be using the median, the 5-number summary. So this is why we're really only concerned now with symmetric distributions, with normal distributions, really. So if the calculator that we looked at back in chapter 5 was a couple of them. If you watch my videos, I've pointed you to both of these. But the one I want to talk to you today about why is it okay to have n times p is bigger than 5 or 10 or whatever you want to do. So if I have I don't know, let's see, what if I have 10 and I have a probability of success of 0.2? We'll do something that I know won't work. Okay, I see a skewed distribution that is certainly not normal. So if we do the n times p thing, 0.2 times 10 is only 2. That's not greater than 5, right? So it's not, that tells us without even having a graph it, it's not a normal distribution. Even though 0.8 times 10 is bigger than 5, both conditions need to be met in order to give this a symmetric distribution. What if we up it? What if we up it to 20? What if we have a sample of 20? See how that's starting to get a little more symmetric. Still, it's skewed. Let's see if that holds for the 5. So 0.2 times 20 is, what is that, 4? Oh, see, that doesn't work. See, that's a 4. That doesn't. So what if we make it be 30? Now that is starting to look more. Now watch 30. 30, that's 6. That's right. So point um 0.2 times 30 is 6, and 0.8 times 30 is bigger than 5. It's whatever what would that be? I don't know. Yeah, 24 is it? So that's bigger than 5 also. So this is starting to get more symmetric. Dr. Stevens says that's close enough to a normal distribution to use it. Now, what about MyOpen Math 10? Well, could I convince you this does look a little right skewed? So if we use MyOpen Math 10, let's make this be, I don't know, let's see, what's 30%? If we want, won't that have to be 50? Let's clear this out of here. So you see now that's looking very symmetric to me. And 20% of 50 is 10, and 80% of 50 is bigger than 10, would be what, 40. So that's why MyOpen Math is having us use the little bit stronger thing. Honestly, I don't think they mark it wrong if they give you stuff that'll work. Okay, but that's why we're trying to get a symmetric distribution, a normal distribution, so that we can use the mean and standard deviation, talk about center and spread. Okay, so that's why MyOpen Math's doing that. And Dr. Stevens is doing that.